Hello. Hey, how are you?
I'm doing well. About you?
I'll be conducting today's interview. A few things about the logistics. We'll do the introductions for the first few minutes, and then we'll move on to the coding exercise. In the last 4 or 5 minutes, I'll share my feedback.
Okay. Sounds great. Thank you.
Is this your first time doing
This
the
is
mock?
this is my second mock interview. I've used it last time. I'm not like I'm not very fluent with it, but it's pretty straightforward for the most part.
So yeah, I will copy and paste the problem. But can you before I do that, can you please start sharing the screen on the Zoom?
All right. So I see you've copied a question. Says given a string s and a list of characters curs, return the minimum window substring of such s such that every character in curs is included in the window.
Yeah, so I can walk you through a couple of examples to make it clear. So let's say this is the given string, okay, and these are the list of characters. For example, you'll see that this substring here, this one contains all the characters. This is one option. So if you look at another one, this is another option, but this one is even longer though. But if you look at this one, the last BANC, for example, this also includes all the characters, but it's the shortest substring among these options. So the answer should be then BANC, this one. Mm-hmm. So the next example here, again, this is the given string, and these are the characters. You'll see that this string doesn't contain the character D, so you cannot actually find any substring that contains all these characters, and answer should be empty string. Just like here.
Right.
So one thing that will help is that this character list, this only has unique characters, okay? So this is helpful. It makes the problem a little bit easier than it will be otherwise. So yeah, that's about it. Any questions or any clarifications that you need, just let me know.
So this is not case sensitive. This is like characters just like as they appear. And this is not case insensitive. It is
just for simplicity, we can assume that if one of them is lowercase, the other one has lowercase characters as well, or vice versa. If one has uppercase, the other only has uppercase characters. So just for simplicity, okay. Doesn't matter that much, but yeah, if it's easier, go for it.
Right. And what about the sizes? Like, what's the maximum size of S and curs?
I mean, yeah, you don't need to consider that. Yeah, it's not long enough to blow up the buffers.
Gotcha. Yeah, that's the reason why I'm asking. Okay. So the first thing that would come to mind, which is like a naive solution, obviously, is to just have a nested loop and basically consider all substrings. Like, you start at A and like you keep building up until you can't build anymore, I guess. So how would that work?
Yeah, that's a reasonable start. Yeah, you just have to first find a substring that contains all the characters. That should be the first step. Yeah, makes sense.
Right. So if I have all substrings, basically just pick the smallest of all of them.
But that will be that will be a naive solution.
Mm-hmm. Right. Yeah, that's what I'm saying. This is like obviously the first thing that jumps into your mind. Now let's see if we can improve on that. So the smallest substring would have at least the number of characters in the array, right?
Mm-hmm.
So maybe we can consider all the substrings of that size first, and then see if we can build on top of them to make them inclusive. But I don't like that. I don't feel good about this one either.
I mean, basically, maybe I'll give you a little bit of a hint. So I think for the first thing you have to look for is starting from the first character, just expand them imagine you have some sort of a window starting with the first character and expand it all the way until you come across with a window that contains all the characters, right? So let's find that window. So it's all about what you do after that to efficiently search for all possible substrings and and finding the one with the minimum length among them. And I think maybe you can think about what you can do from that point on. Maybe another thing you can another thing you may consider is once you have that window, so obviously you have to expand that window somehow, and also at some point maybe that window gives you enough information so that you can start shrinking it from the other end. So that way, just by alternating shrinking and expanding, you can process the entire string, and maybe we'll do that efficiently because if you run a window across the string, it should be a somewhat linear algorithm. I think. But it's all about how you process that window.
Right. And I'm just writing down kind of what like I'm thinking the algorithm should be. So like start with basically like from the beginning. Once I see a character that is included in the array, then that means I'm at the beginning of a potential substring, right? So I can keep adding characters on the right from there until I find a substring that has all of them, right? And that would be one of the candidate substrings. Now after that, I would probably want to look inside of that substring to see if there's an even more a smaller substring. But no, I don't really like that either, because there could be like, if I do find that substring, there could be like a part at the right hand side that if I do add from the right side, it would create an even smaller one. So this solution wouldn't work. Okay, one more thing. Give me 1 second. Let me just think about it real quick. So are you suggesting that like this would be like some greedy strategy? It's not like an exhaustive search, basically, right?
I mean, it all comes down to doing an exhaustive search somewhat, but doing it efficiently, as you said. I mean, I don't want to necessarily say it's a greedy. Maybe it's a greed, some sort of a. It's essentially a greedy algorithm because actually, let me point you to this, and I think from here on you should be able to figure that out. So let's say for this example, okay, let's say this is the first substring you come across with, right?
Mm-hmm.
So again, depending on what structure, what extra data structure you use and how you do the computation, that I don't want to reveal. But at this point, okay, so let's say this is our window. So if we shrink this window in hopes of finding something smaller in length, so let's say DOBEC, right? At that point, that substring doesn't contain all the characters, and basically that tells us that there is no shorter substring than that ends with C, okay? Because I mean, of course, if we had AA here, that would have been a different story. But in this particular case, based on the characters we have, so here, once you shrink the window from left, and when you are here, you are guaranteed that there's no point shrinking that any further while fixing the right pointer on the C, because Basically, that's the shortest, right? So at that point now, since you know that there is no need to go any further, now you can start expanding again, okay? So let's say we expand again, so this doesn't contain that missing character, so you have to keep expanding again until you see that missing character.
But I can't expand from like from after the first substring. I'd have to start with D, like the second character, right?
Yeah, because you have to first make sure that you have the shortest substring that's ending with that character on the right, right limit of the window. Once you know that for sure, you can now start expanding again, because that's basically your shortest up to that point. So now you have to check other possible substrings, whether they are shorter or whether they are shorter or longer or whatnot. Yeah.
Mm-hmm. Okay, so basically it would start not with a nested loop. It would basically be this is pseudocode, by the way. Let's just do this. What's that? What will actually bring so we can find smallest, and then if it's string S, and character array C, right? So it would go something like for int I equals 0, I less than S dot length plus I, do basically start with the character at I, and then keep trying to add characters to the right until you find a substring that that basically has all the characters in the array. So start with this car and add from right until you satisfy condition. Now, if one is found, try to minimize it. And that would be basically remove cars from the left as long as the condition is satisfied. And now, like once this breaks, then I would need to basically say, okay, well, I can't take any more characters from the left side. And this is the smallest substring that I can get from here. And then save that string like somewhere basically as a potential solution. And then basically continue, but then my continuation has to be from I plus 1 and not I plus the length of the string that I found, right? And basically keep going until I find like the smallest substring possible. Like I'm minimizing over that substring. Does that sound okay? Let me think about it.
Yeah, so far so good.
Cool. Now the question is, how do I do this in an optimized way? Now the question becomes, does that substring have every single character in the array? And one way to do that is basically to have, I mean, I can obviously sort them both and like kind of see if they're matching, if like the first n characters match and n is like the size of the array. That would be one solution, but let's see if we can do better. There's basically you can use kind of like a map that says this character has been found, this character has been found, and then basically iterating over the map afterwards and seeing if all of them have been found. The complexity of this, if it's like a hash map, basically would be order like n, basically it would be linear. So that would be a more optimized way of checking if the substring basically has every single character in the array. And I think that makes sense. I don't know if we can optimize beyond that, but let me think for a second. Okay, let's start with that and then we can think about optimizing it farther down the road. Is that okay with you?
Yeah, sounds good. Fair enough.
Okay. So
probably a good idea to start coding.
Yeah, that's what I'm doing. So I'm gonna have this string buffer, or string builders is what it's called in C#. SB equals new string builder. Oh, let's yeah, so string builder, and then is it okay if I search for the API?
I'm not sure. Why not? Go for it.
And pending clear. Okay, so SB dot append S of I, and then for int j equals I plus 1, j less than s dot length plus j. Basically, SD dot well, let's see. Let's have this map here. Let's call it dictionary. So I'm gonna have a dictionary of character and Well, does it even have to be a dictionary? Like, could just be an array, but
Yeah,
let's.
yeah, because you may have multiple. I mean, you have to keep count of the characters probably. Otherwise, that shrink. Determining when you cannot shrink any further could be tough, right?
I have to keep count because if.
I mean, if you have, for example, if you
Oh,
have,
yeah. I
you
see
know
what
what I mean? If you have duplicate characters, then how can you determine if you cannot shrink any further? So you have to have the count information so that you know how many times that character appears in that window.
Right.
Otherwise, you will start shrinking, and you may think it's okay to shrink any further. When in fact, there are no more no more of that character in the string. So that's why.
Mhm. And then to initialize this, we are fixed of c equals 0. So when I'm starting back here, like when I'm appending basically to the string builder, I'm gonna say counts. Well, first of all, I need private static void init dictionary, and then this takes a dictionary of color and counts. So that initializes it, and then now counts of s of I. Well, that's but I don't want to. Okay, counts of s. That's fine. Now, basically, what I'm trying to test for here is that if I add another character, would that satisfy the condition, basically? So let's write this private static bool satisfies condition, and that takes the string builder s, and it takes a car array cars, and it takes this as well, the dictionary. Does it need that? Just needs these two. So for each car C in hers, if counts of C greater than 0, or actually less than 0. Oh, sorry. Less like equal 0. Then return false because there's one character that wasn't included. If that succeeds, then return true. Okay. Now, if like I need to check like what if cars was just one character long, right? So like I need to check if satisfies condition. Or rather, if not satisfies condition. Oh, by the way, can these can this array be like empty?
Which one? Yeah, it could be, potentially. Yeah, why not?
Okay. So if it does not satisfy the condition, then start trying to add to it, basically. So speed of fn s of j, and then counts of s of j plus if satisfied condition. Great. Okay. But I have to clear here first. Okay, so at this point, basically, I know that after this loop, sorry, after I exit from here, okay, so by this point, if I found one, then I would need to start seeing if I can make it shorter. And okay, start try to make it shorter. In order to do that, I'm gonna start trying to remove characters from the left side. I less than SB dot length plus I. And then I can just say counts of SB of I minus minus. Let's see. Counts of if, well, actually, I don't need to do this right now. If satisfies condition, if it still satisfies the condition, then I can do remove SB dot remove the leftmost character. This basically says the index and the length. So remove the left from the leftmost one character. It does satisfy that condition. Else. Break. All right, so if I found it and I kept basically if it satisfies no, that's gonna mess it up. Yeah, I feel like I guess like I'm gonna have SB dot length less than furthest dot length, then short this. Well, I can do this here.
Yes. Have you tried this on an example? Oh, satisfies condition. Oh, okay. We are now. You're trying to implement. Otherwise, I think the rest of the rest has been implemented. It seems. So it all comes down to figuring out. Okay, I see.
Do you want me to like run this through an?
No, it won't. No, it won't run because obviously without. I mean, if you think it's done, then obviously you want to start running it because.
Yeah, we only have 10 minutes or
yeah, about 10 minutes left. So I mean, it's in your best interest. I don't want to rush you, but.
okay. I'm just gonna write like a test case here, but like I'm not gonna run it until like I just proofread it first. So let's say find. This obviously needs to return something. I'm just gonna try to run to see if there's compilation errors or stuff while I'm doing this. Look available, I cannot be declared. 59. Oh, we're in. Oh, obviously. What? It's declared right here. String builder. This is weird. Like string builder, it's declared right here. I don't know why it's not happy with it here. Okay, so for the sake of time, I'm just gonna try to like run through it by hand first. So let's say I go here, and I probably should have done this before writing the code. I know that this is not good. So I look at A, and then basically I say if it doesn't satisfy the condition, try to append D, and then like just add to the count. And if it satisfies the condition, it does not satisfy the condition, then keep going with this loop. So it's going to add O and B, and then E and C, right? So I would have, like, once this is done, I'm going to get here and I say, like, yes, there's something that's been found. Let's try to make it shorter. I'll try to remove from the left. And once I do that, then I'll break the condition by removing the A. So this is not gonna work. Satisfies condition. So it wouldn't satisfy the condition. So I'm gonna come into that else here and say, okay, well, I haven't removed anything from the string builder, so it's still like the smallest one that I found, but like I need to compare it with the shortest string, like the ultimate one. And if it's shortest, it's shorter, then like set shortest to that string builder that we have so far. And then go back to the D basically, and then say D, O, B, C, D, O, B, E, C, O, D, E, B, A. That would be the next one, right? A, B, C, yeah. And then I'll basically, here in this situation, I'll get into the other loop, basically, where I can actually remove from the left. So I'm going to remove the D. If I remove the D, I still have A, B, and C. Oh, so here's a bug, basically. Like, it doesn't make sense for me to start at an I that's like not even included, right? Like it has to start with an element that I do have. So can we do that?
One second. I didn't catch that.
So what I'm saying is, like, once I get here, like I'll find the next substring. So it's like D, O, B, E, C, O, D.
Okay, yeah. I see. Okay, and an A. Yeah.
Right. So, but it doesn't make sense for me to even consider that, because like that D is not even included here. So why do I even look at it, right?
No, that's fine. That will be taken care of as you start shrinking from left, right? As you keep shrinking and shrinking, you will remove that character from the. I mean, you will remove the counts and potentially the character itself from that hash map, and you will see that it won't impact because it's actually yeah, you know what I mean. It's not actually one of those characters that makes up the character list. So, but the one thing that you probably haven't addressed is how you are going to determine if the given character is part of your character list, because there are a couple of ways to do that, and one is obviously more efficient time wise, and the other one isn't. So this part, I think this code still miss of. Oh, I see. Yeah. So this for each cat. Oh, okay. Yeah. This probably is not. This obviously not an efficient way to do that, because you are iterating through the list. There's probably. And we only have about 5 minutes left, so I guess it's just about time that I start giving you some feedback. So overall, maybe one thing I can give an advice is you probably want to practice problems that combine either multiple I mean, it's kind of rare though, where you will be asked to implement multiple algorithms. But what's more common is rather than doing, for example, a question on binary search or just DFS or BFA recursion or whatever, it's always a good idea to practice problems where you have to combine this algorithmic technique with a data structure. So this is one of those problems. Here you have to do this window. What do you call there? What is it?
Like a moving window kind of.
Yeah, exactly. A moving window along with a hash map and potentially another data structure. That another data structure is needed for quickly checking whether the character you come across with is part of your character list. So and so on and so forth. So I think it's a good idea to practice those kind of problems at some point. If this is this is the beginning phase.
Right.
Another thing, but otherwise, I think overall, again, the right approach is to try to come up with the solution as much as possible, and then starting the implementation, which you did, by the way, so that's okay. As far as the tips are concerned, I might have given you maybe a more more than acceptable, but that's quite subjective. Some people may find it more than necessary, and some people may be okay. I'm usually more lenient in that regard, but some people you don't really know if the interviewer will be okay or not. So I think the less hints or tips you need, the better it is, especially during the solution phase. If you can come up with the solution yourself, and then if the most of the hints have to do with some minor stuff in the code, that's usually more acceptable. I'm just giving you this as a friendly advice.
No, I totally get that too. Yeah, you're absolutely right.
Yeah. And the other thing is, of course, you want to definitely watch out the time. And here's why I'm telling you this. This may be okay for some companies, but so this is a medium level question, okay? Mm-hmm. It's maybe a little bit on the hard side of the medium, but nonetheless, it's still considered medium. And this was in fact one of the problem. This was a problem that was given to me by Facebook in one session. So Facebook usually gives you or expects you to solve 2 medium level problems in one session. Right. So that means you have about 25 minutes to spend on each problem, and that means end to end, from solution to a coding to a working state with all the testing and whatnot. So why I'm telling you this is because one way to determine that you are ready to take the real interview is if you can randomly pick a medium level problem from LeetCode, and if you can do it end to end in 20-25 minutes, that's a pretty good measure of readiness for the real stuff.
Right.
That's I think overall that's all I can say. I will give you. I'll maybe put a more detailed write up later. But in the meantime, if you have any questions in specifics, I'll be more than happy to answer. But that's all I can say based on what I've seen so far.
Yeah, and I totally agree with you. Like, I honestly was just kind of out of it today, unfortunately. But I totally agree with everything you said, and usually that's how I would like to kind of approach these kinds of questions. It's obvious that I need to practice more, and I need to kind of go heads down and apply the feedback that you're saying, and maybe take more of these mock-up interviews and keep collecting feedback.
So another way, actually, that I mean, all these things are very subjective, and it depends on the person. But one other suggestion is, at some point when you feel more or less you are ready for the stuff, it's a good idea to start taking the real interviews with the companies that you wouldn't really you wouldn't quite consider maybe joining in the first place. That gives you you can consider that as a practice, but as real as it could be. So that's what I do personally, because practicing on LeetCode and all these mocks, they're obviously necessary. I'm not taking anything away from them, but how you behave, how you handle your nerves in a real interview setup, that cannot be taught in a mock interview, because at the end of the day, that this is a mock interview, and the concept, there won't be real world consequences, whereas the other one, you are on the spot, and it's again, this is maybe your personality is different, but usually you may be more on the edge in that real
Yeah, oh,
interview.
absolutely. I was definitely nervous even in the mock interview. So
Yeah, I mean, yeah, I'm just saying these things because I've been through them so many times. I don't know, maybe I interviewed more than 100. I've done these things maybe more than 200 times. I don't know how many times.
wow.
So, and personal interviews again, I have gone through so many interviews with all these big companies, smaller ones, hedge funds, etc. You know, that at some point you really calm down and you know your nerves settle, but until then it's not a pleasant um, affair, so to speak.
Yeah, no, for sure. Yeah, I would definitely rather not be like, because so honestly, like I feel like if I wasn't in an interview, like this is not such a hard problem. Like I feel if I just wasn't like kind of
But I'll tell you this: this is not, yeah, this is not a terribly easy one either, because I'm telling you, Facebook used to, used to give people two problems in one session. So this was actually this was the only problem. But then I got a follow up as well, and the follow up part was a little bit more difficult, maybe hard, can be considered the hard level.
Mhm.
But that's how it was in that interview, and yeah, it went fine. But you don't really know these things. Usually, you know, people are under the impression that they don't give you hard level problems, and I'm telling you from my own personal experience, that's not the case. I had an interview with Facebook that I got a relatively hard dynamic programming problem as well. So it's better to be prepared. But what I'm saying is, don't go too far with the preparation either. So I don't know how many questions the lead code has. Maybe more than 1,500 questions, I'm sure. So there's no point trying to solve 1,000 questions. You know, once you solve maybe 100 questions, 150 problems, as long as you cover a decent base, that should be enough. At least that's how it works for me. You know, I don't try to solve that many problems. It's
Right.
really the way to measure how well you are prepared is, again, just try to pick a random question, medium level, and then if you can do that in 20 minutes, 25 minutes, let's say, that's a good place to be as far as this thing is concerned. All right.
All right. I really appreciate your time and thank you so much for all the great feedback. It's awesome. Thank you so much.
Yeah. All right. Yeah. Thank you. Wish you good luck.